Yes, class. Am I audible to all of you? Rajita, you didn't join the previous class. Deborah, you also. Mir Hussain, you people weren't there. Fadil was there. Sidra was there. Amna was there. Ray optics, you people do not have to do. Deborah, you weren't there, no?
Ma'am, I was there.
You were there, Deborah. Okay, okay. Deborah was there. Rajita and Mir Hussain, you both weren't there. Mir, you already don't attend classes in any ways. See, ray optics will be done in that batch only. It won't be repeated here. Other students are also joining. They are also taking extra classes. So if your batch has started late, you people also have to take extra classes. How will you cover up the syllabus then? Now see applications of Ampere circuital law. Ampere circuital law we did in the last class, remember? So basically the law, Ampere circuital law said that line integral of magnetic field is mu naught times the current that is enclosed. This was the law that we had seen. Now see, you have to choose an Amperian loop. So when I said no, we have to take two devices, solenoid and toroid. Till here you people have written. Derivation part is left. See what we'll do, the entire curvature helical part that is present. This is very difficult to be depicted over here. So what we do to, in order to check the current which is going inside and coming out, we'll cut this. So what will happen? This part will be visible to us and this part will be. We'll be cutting it transversely. So what will happen? We'll just see, so we'll be just able to see the current that is present. Now see, current is moving outwards. This is outwards, this is inwards. It means current is coming from here, going inside like this. Coming here, going inside like this, like this. These are the curvatures. Whatever was the curved part, no, in between that I have deleted. Fine, so that at least we just have the points where the current is entering and the current is leaving. So these are the points where the current is entering, like outwards. When the current is going outwards, this is then going into it. So it means these are connected. These points are not separate, or this is not a separate rod which is present. Current which is present outwards, current which is present inwards. So it's like from outwards this is coming, then going inside it. Then this is coming outwards, and then again this is going inside. Then this is coming outwards, again going inside. Like this is the helical path which is formed. Because I told you in the last class, solenoid is just turnings of copper wire. So these are the turnings which are present. So from this point, the current is coming outwards. From this point, the current is going inside. Now see, when we have to perform the derivation for Ampere circuital law, the first step that I told you is that you have to choose an Amperian loop. So here also we'll be first choosing an Amperian loop for the calculation. See, now I'll choose the Amperian loop in such a manner. See, I have to include this outside area also. I want to include this area also. And I want to include this area also. Now see, this I have taken. This is the square that I have taken. This is the Amperian loop. Now this is, see, I have to include this part also. So a little bit from here also I'll take it. Now this is fine. This is covering some portion from here also. This is covering some portion outside also. This is covering some portion inside also. So this is A, B, C, D. This is the Amperian loop that I have made. Now see, how will we solve Amperian's law? Amperian's loop, how will we solve Amperian's law? So the Amperian loop is A, B, C, D. So we'll integrate this. First, we'll find out the line integral of AB. So we'll basically divide it into 4 parts. Look, this is the Amperian loop. This is one segment. This is one segment. This is one segment, and this is one segment. So see, obviously you cannot find out the entire area, no? Different portions are included. This is outside, this is lying within, this is covering a bit of magnetic field. So what we'll do, we'll take it into parts. So B dot DL, this is just, we are integrating the left hand side. Fine, this is just about the left hand side. Right hand side I've not included. This we'll complete, this we'll equate it. Let us just have the value of integral of B dot DL first. Then we'll equate it to mu naught I. So see, integral of B dot DL is equal to integral of AB plus BC plus CD plus DL. Now, here also the difference that will be arising will be integration of BDL cos theta. So see, for AB segment, look, this is just parallel. This is exactly lying parallel to the magnetic field. This is, this is lying parallel to the solenoid. So here, BDL, both the angle, this is 0 degree. When we are talking about BC, look here, BC is perpendicular. This is perpendicular. This is making an angle of 90 degree. So here this becomes integration will become BDL cos 90 degree. Plus CD when we'll take. Again, this is also parallel. So 0 degree and DA, this making an angle of 90 degree. So this will be integration from BDL cos 0 degree plus integral BDL cos 90. Now, when you are integrating it, when you are solving this, best part is that this term, this will be 0. This will be 0. So you are just left with BDL cos 0. Here also you are left with integral of B dot dl. So magnetic field take common, integral of BDL. Here also take magnetic field outside common and BDL. Now when you are integrating the entire length, when you are integrating the entire length, you are left with B, L from here, length is L. This is 0, this is BL, this is also 0. So basically, you have obtained, this is just one side of it, one portion of it. Fine. Now see one more thing. This is not complete. What is the final answer then? Integral of BDL. 2BL. See, it won't be 2BL. Why? Because when I'm talking about the segment CD, it is outside. Do we consider the segments which are outside? Why don't we consider it? Because magnetic field outside the solenoid will be 0 in any place, because the magnetic field lines are not existing. This will be 0 automatically, right? So it means here magnetic field itself is not present, whether the angle is 0, but despite the angle being 0, here magnetic field is 0. So here also this will eventually, it will also become 0 because of absence of magnetic field. So integral of B dot dl is BL. Now see class, number of turns per unit length is N. Number of turns per unit length. Please class, be careful whenever you are solving questions of solenoid. This is not just number of turns. This is number of turns per unit length. So for L length, you will multiply. If for unit it is N. So for L length, it's like for 1 meters, it is N, number of turns. So for L meters, NL. So BL is equal to mu naught I is there. But this is just for one turn. For L turns we have, L length, number of turns we have, N, right? So what will happen? Length will be cancelled. B is equal to mu naught N I we are having. This is the form. Now be careful with this. N is not number of turns. This is number of turns per unit length. Number of turns per unit length. Also, one more thing I'll tell you. Number of turns per unit length means number of turns, if this is N per unit length, this has to be taken. You have to check whether small n is given to you or capital N is given. If capital N is given to you, then you have to divide it by length and obtain this. If directly number of turns per unit length is given, then you cannot use this. So first your work is to identify whether small n is given to you or capital N is given to you. Also, one more thing, when we are calculating the magnetic field for the solenoids towards the ends, this is not towards the ends. Though we usually talk about long solenoids, there this isn't needed. Just for additional information, towards the ends, the formula is actually B is equal to mu naught Ni divided by 2. This is the formula. Fine. Also, see, mu naught is coming. So if some permeability of the core is mu r, that is relative permeability. This means the medium has changed. Medium has changed. So if the relative permeability is mu r, simply multiply mu r ni. Mu naught, mu r ni. Let's see questions also. Quickly write down this derivation. Till here, you people have already written from solenoid start.
Ma'am, can you explain the permeability point again?
Permeability is the same permeability which we have discussed in Biot-Savart's law. Permeability is basically how the magnetic field changes with respect to medium. Different media are present, no? So with the interference of different types of medium, how is the magnetic field changing? So that value is governed by permeability. See, this question says that a solenoid coil of 300 turns per meter is carrying a current of 5 amperes. Length of the solenoid is 0.5 meters. Radius is 1 centimeter. Find the magnitude of magnetic field inside it. See, length is given as 0.5 meters. Radius is given as 1 centimeter. This basically shows that length is very much greater than r. So this clarifies the point that this is a long solenoid and you can use the formula B is equal to mu naught Ni. Just for that purpose, these two are mentioned. So mu naught 4 pi into 10 to the power minus 7. Number of turns per unit length, 300 turns per meter. Current is 5. So this becomes 6 pi into 10 to the power minus 4 tesla. One more similar question we'll do. See, this says that a solenoid of length 0.5 meters and radius 1 centimeter, and it is made up of 500 turns, carries current 5 amperes. See, the question is same. The difference that is arising is this is just given to you as 500 turns. In the previous question, it was mentioned 300 turns per meter. See, length is a number of turns per unit, length is not mentioned. See the unit 500 turns, that's it. So 500 turns per unit length, that will be small m. Now see, value of L is 0.5, radius is 1 centimeter. So length will be greater than R. See, this data for radius, no, because see, area is not used over here. Radius is only given because you have to confirm this. When nothing is mentioned, then by default, it's already a long solenoid. In these two questions, it was mentioned, it can happen that it is not mentioned. So B is equal to mu naught Ni. So this is 4 pi into 10 to the power minus 7. Now small n is what? Small n is number of turns per unit length. So number of turns 500, length 0.5, current is 5. So this will be, see, this will be cancelled. 5 into 420. So 2 pi into 10 to the power minus 3 Tesla. This is the value of magnetic field. Write it down. See, and the solenoid was a straight device. Now, if you curve it and make it in the form of circle, that becomes toroid. So, solenoid bent into the form of a closed ring is called a toroid. Now, see, the difference that will come is here the length was the length of the entire solenoid. But since this is a curve, so length of the circle will be 2 pi r. That will be the difference that will be coming. Now, see again what we have done. This way we had taken the cross section in the solenoid also. This is the way we had taken the cross section outwards and inwards. Since this is in the form of a circle, these two concentric circles are basically representing the lines also. So first region, 3 regions I'll be taking the way we had taken the Amperian loop and solved it. So first Amperian loop is this, because this is a circle, so circular Amperian loop. Second, I am taking it from within, so that portion of magnetic field lines are also included. So radius is R2 and 1 I am taking it outside. So this is R3 first, second, and this is the third one. Now see, when we are talking about space interior to toroid, B dot dl is equal to mu naught I enclosed we'll be considering. Look here, B magnetic field is not present within. In the region first, there is no presence of magnetic field. Magnetic field is there only in the second region, not even in the third region, not even in the first one. So directly magnetic field will be 0 in the first one. Current is the I is the current in a single loop. So that's why we multiply it with number of turns. Now see, in region 3 also magnetic field is not present. So when you will be writing B dl integral mu naught I enclosed in the third region also, this will be 0 straight away. What about the region 2? In region 2, we will be integrating it properly. Integral of B dl is equal to mu naught I. And number of turns also, n we will multiply. So dl, integral of dl for a circle, because this is a circle of radius r2. So this becomes 2 pi r2 is equal to mu naught I n. So this becomes mu naught n I divided by 2 pi r2. This is for second one. Third one is also 0. So what is the net magnetic field? Net formula of magnetic field, this is mu naught Ni divided by 2 pi r. I'm only writing r because other radius didn't work. The other radii didn't work for us. We don't need them. So I'm just taking one radius. Now see, if I say this number of turns per unit length, this one number of turns per unit length, if you see this number of turns by 2 pi r. 2 pi r is actually the length of the circle. See, n is the number of turns, 2 pi r is the length of toroid. So this is ultimately the same formula. This formula, you can say n by 2 pi r is equal to number of turns per unit length. So you will here also get the same formula, B is equal to mu naught Ni. So this will be mu naught 2 pi r. So this part is basically your small n. So small n is equal to number of turns by 2 pi r. Fine. Now see, when we are taking inside, this is the earlier question which we did in the last class. Look, in the last class, we had taken this question. Remember, we had taken a point inside also, we had taken a point outside. This question I'm referring. I told you this is a very important question. So if we have chosen points inside, that is radius is less than a. So radius of Amperian loop is this. This was the formula we obtained. B is equal to mu naught IR by 2 pi a square. And outside, that is R is greater than A, we obtain the formula B is equal to mu naught I by 2 pi R. So when you see the relation with R, magnetic field are directly proportional. Magnetic field are inversely proportional. So the formula, the graph will look like inside it is directly proportional, then this is at the surface, then outside inversely proportional. So this is with reference to that question only. Just make a star mark over there and add these points. First, write down the derivation of the toroid. the magnetic Lorentz force. This is the next topic. Now, a Lorentz force, first, before we discuss in detail, we talked about electric force. What was electric force? Electric force was basically QE. Force was charge multiplied by electronic configuration. Or you can say electronic charge. But that was when electric field was present. If only magnetic field is present, now the force that will be acting will be simply known as magnetic force. So its formula is Q. The way electric field was present here, instead of it, just we have V cross B. So FB is equal to Q VB sine theta. Now magnetic field, if it is in one direction, charge is also flowing in the same direction. So angle between them, theta will be 0 degree. So FB will be equal to 0. This is what is your formula. This formula is very important, QVB sine theta, or you can say QV cross. Also one more thing, see, this is an important question that comes in exam. To prove that the initial and final velocities are same. See, force is perpendicular to, if this is the condition, if the force is perpendicular to velocity, force will also be perpendicular to displacement. So theta will be 90 degree, right? If force is perpendicular to displacement, this makes angle as 90 degree. So work done is F dot S, that is Fs cos 90 degree. Fine, this is Fs cos 90 degree. That is simply 0. See, if work done is 0, work done by magnetic force is 0. So according to work energy theorem, all the work done is converted into kinetic energy. In class 11th, you people must have done work energy theorem. This is how to prove it. Please pay attention. If this is the condition that force is perpendicular to velocity, velocity is rate of change of displacement. So force is also perpendicular to displacement. If force becomes perpendicular to displacement, that is a case of 0 work done. Work done isn't there. There is no change in kinetic energy. It means you can simply say kinetic energy final minus kinetic and energy initial. This is the change in kinetic energy. This is 0. This is 0. Right? So it means there is no change in kinetic energy. If there is no change in kinetic energy, we can say kinetic energy initial is equal to kinetic energy final. So what is the value of initial and final? Half mv final square is equal to half mv initial square. Half m cancelled. So v final is equal to v initial. This is a proof that comes. So this is the case only when there is no change in the velocity. So this is the only case. This case will come only when the force is perpendicular to displacement. Now, regarding these formula, there are 4 cases which we have to discuss. 2 let us discuss. Then you can write it down. Then we'll see. If charge is the direction of velocity is same as that of magnetic field. So here, the value of theta will be 0 degree. So FB will be Q VB sine 0. So magnetic force will be equal to 0. This is equal to 0. So magnetic force is equal to 0. If it is anti-parallel, charge is moving in opposite direction to that of field. So theta will be 180 degree. So force, magnetic force will be Q VB sine 180 degree. So force will be 0. So if charge particle is parallel to magnetic field, if charge particle is anti-parallel to magnetic field, in both the cases, you will be getting this as 0. But I told you there are 4 cases which we have to discuss. 3rd and 4th I'll discuss later. First, you write it down from here. See, in the third case, if the magnetic field and the charged particle which is moving both are perpendicular to each other. So see here, when we apply right hand thumb rule, velocity is downwards. So keep your palm downwards in such a manner that you curl your fingers towards the magnetic field. So see, when you are keeping your palm downwards, your magnetic field is inside. So curl the fingers inside. Where is the thumb pointing? Thumb is pointing in this direction. Tell me for this one. Palm is facing the screen, pointing towards the right hand side. Curl the fingers inwards. Where is the thumb pointing? Answer in the chat column. What is your direction coming? See, palm is kept towards the screen. Means your right hand is kept. You have to keep your hand in such a direction that you are able to curl it towards the magnetic field. So curl your fingers inwards. Where is the thumb pointing in this case? Yes, Sidra. Answer. Upward. Amna says upward. Sidra, Deborah. See, upward is correct. Your hand is pointing towards the right hand side because of the motion of the charge. When you curl the fingers inwards, thumb is still pointing upwards. What about this? This answer, all of you. Third one. Deborah, your answer is right. Left. See, when you are keeping your hand in the direction, the fingers are pointing upwards, right? When you're curling the fingers, inwards, thumb is still pointing in this direction towards the left. So left is correct. What about the last one? Rajita, your answer also. Rajita, you're present.
Yes, ma'am. I was about to send the answer, but then you said it, so I left it.
Okay. Just tell me for this one.
Down towards the
Downwards. Very good. Perfect. See, when you people are keeping your palm towards the left hand side, curling finger inwards, thumb is still pointing in the downward direction. Very good. So I hope this concept is clear. Now see, these are just 4 random points which I have taken. If I take all the points collectively, can you see all the forces are pointing in the center only? There is a, this is just the rule. This you people already know. So what is happening? When we are taking all the points, so ultimately all the forces pointing towards the center. So this magnetic field which is present, this is actually providing the necessary centripetal force. Centripetal force you must have done in the class 11. Let me just repeat it. So centripetal force is what? The direction of centripetal force. 2 things you have to remember. One is along the radius, second is towards the center. Any force. See, centripetal force is not an actual force which is existing. Basically, different types of forces are present in nature which are performing the function of centripetal force. Wherever you see any force which is directed along the radius towards the circle, towards the center in a circle, it means that force is providing the centripetal force. Centripetal force's formula is mv square by r, but this is not an actual physical force which is existing. Some or the other force will be providing this, so we'll equate it with mv square by r. Or you can write it, see, omega is equal to v by r, so centripetal force will be m omega square r. This is it. So here also, here what can we observe? Here we can see that the magnetic force is providing the centripetal force. Magnetic forces QVB and centripetal forces mv square by r. So can you see both of these are actually equal? The centripetal force, let me write it with a small r. So centripetal force is provided by magnetic force. So we can say QVB is equal to mv square by r. So velocity will be cancelled. Velocity is QBR divided by m. This is the, now you have so many formulas to remember. What is the radius from here? Radius is mv divided by qb. So this is what is the radius of circular path when an electron or any other type of charge, not electron specifically, moves in a circular path. This is radius of circular path. One more thing. Time period is what? Time period is distance by velocity. So circle's distance will be 2 pi r, velocity is v. We have calculated the formula of velocity right now. What was velocity? QRB by m. Huh? So QRB by m. RR will be cancelled. What is the formula of time period? 2 pi m by qb. All these formula you have to remember. And one more thing. What you have to notice here that time is independent. This is very important. This comes a lot. Independent of radius and velocity. And even in your entrances, this question has repeated a lot. After class 12, whatever entrances you will be appearing. Time period is equal to 2 pi m by qb. Write it down till here. Some more formula we'll discuss. But first write down all these points because this is also a lot to write. 4 cases are there. First 2 cases were very easy. So we did it easily. Third case is lengthy. Fourth case also needs to be discussed. you all have completed, you can leave. Please attempt your after class assessment. Tomorrow we'll continue this.
Thank you.